C++ user-defined function types for better understanding of arguments and return in functions. User-defined function can be categorized as number one, function with no argument and no return value. Number two, function with no argument but return value. Number three, function with argument but no return value. Number four, function with argument and return value. For better understanding, consider a situation in which you have to check prime numbers. This problem is solved by making user-defined function in 4 different ways as mentioned above. First of all, write a C++ program to check in given number is prime or not. We perform this task with 4 different user-defined functions. Number one is no user-defined function with no argument passed and no return value. Code. When we make any function with no argument and no return value, it neither receives any data from the calling function nor return a value. In other words, we can say the calling function does not get any value from the called function. In this code, we declare a function with the name prime and we have no return value, so we put our keyword void in front of it, and as we have no argument to pass to this prime function, so we keep the parenthesis empty. So the function is declared at void prime and empty parentheses. Then we start our main program. In main program, we call our prime function. As this function has no argument, so we call it with empty parentheses, and also this function does not return any value, therefore we did not equal it to any variable. After that, main function is cleared. When compiler goes to prime parentheses, then control function, which is declared as void prime with zero argument or empty argument, mean empty parentheses. As this prime functions use no arguments or parameters, therefore we define all its variable within the function and we display or take values within the function body. So first of all, we declare 3 variables with integer type data int. So int num I flag, and we put flag is equal to 0. We declare 3 variables. First of all, we use variable num to take the input from the user. So enter a positive integer, then user enter the integer. Then we place a check on this integer whether it is a prime or not. For that we use for loop and we set the condition I is equal to 2, so that I less than is equal to num divided by 2 plus plus I. It means any number which is divisible on itself or 1 is called a prime number. So if num modulus I is equal to 0, then a flag is equal to 1. Then we break our for loop and if flag is equal to 1, then we uh, print that number is not a prime number. Otherwise, we print on the screen that number is a prime number. So here is the output of our program. For example, user enter an integer value 9. So after checking the condition, 9 is not a prime number. In the above program, prime is called from the main with no argument. Prime takes the positive number from the user and check whether the number is prime number or not. Since return type of prime is void, so no value is returned from the function. Solution 2, no argument pass but a return value. As this function return a value, so we declare function as int prime and with parentheses because we need no argument, so we empties these parentheses. Into the main program, we similarly to the previous program, we declare our variables which are int num, I and flag, and put flag is equal to initially flag is equal to 0. Then we call our function num is equal to prime. So as this function return a value back into the num, so the remaining check are passed to the num. So after getting the return value, we put a check on this num variable for I is equal to 2, I less than is equal to num divided by 2 plus plus I. If num modulus I is equal to 0, flag is equal to 1, and break. If flag is equal to 1, then cout num is not a prime number, otherwise cout num is a prime number. And then the main function is end. Now function as the return type of function is int, so int prime empty parenthesis, then we write the body of the prime function int n. N is used to take the input from the user in. So printf or cout enter a positive integer to check, then c in n. Then we return this n back to the number n. Output of the previous program is look like as for example, if user enter number 9, then after checking the condition 9 is not a prime number. In this program, prime function is called from the main with no arguments. Prime takes a positive integer from the user. Since return type of the function is an int, it returns the input number from the user back to the calling main function. Then whether the number is prime or not is checked in main function itself and print on the screen. Solution number 3. Solution number 3, argument passed but no return value. In this function we declare a function as void prime and into the parentheses int n. So in calling this program, we see that we take its data type as void because we did not need any return value, but we need an arguments, so we take a argument int n. Now in the main program int num, then we ask user to enter the number. When this number is entered by the user, then this number is passed to the prime function and function is called. So argument num is passed to the function prime as prime num into the num. That as void prime int n and takes the value from the main function and then put the check. So int I flag is equal to 0 for I is equal to 2, I less than is equal to n divided by 2 plus plus I if n modulus I is equal to 0, flag is equal to 1. Then break, and if flag is equal to 1, see out n is not a prime number, otherwise n is a prime number. Of this program is look like as, for example, user enter number 9, then after check, program returns that 9 is not a prime number. So in the above program, positive number is first asked from the user, which is stored in the variable num. Then num is passed to the prime function where, where whether the number is prime or not is checked and printed. Since the return type of prime is void, no value is returned from the function. Example number 4, both argument and return values. So we declare our function with return value and argument, which is as int prime into the parenthesis int n. Then we write our main function. Into our main function, we declare the variable int num flag is equal to 0. Then we ask user to enter any positive integer num. Then we pass this positive integer to the function. Argument num is passed to check function prime into num, as this function return a value, so we return this value back to the flag variable. So we write flag is equal to prime num. Here we call the function. If flag when flag gets the value from the prime function, then we check whether the number is prime number or not, and so we put a check if flag is equal to 1, then num is not a prime number, else cout num is a prime number. Return 0. In our prime function, we returns integer value, so int prime int n, so int I for I is equal to 2, I less than is equal to n divided by 2 plus plus I, if n modulus I is equal to 0, return 1 and then return 0. Okay. Here is the output of the previous program. For example, if user enter the number positive number 9, then after checking it shows us that 9 is not a prime number. In the above program, a positive integer is asked from the user and stored in the variable num. Then num is passed to the function prime, where whether the number is prime or not is checked. Since the return type of prime is an int, 1 or 0 is returned to the main calling function. If the number is prime number, 1 is returned. If not, 0 is returned. Back in the main function, the returned I or 0 is stored in the variable flag and the corresponding text is printing on the screen. So here is a question that which one method is better? Number 1, all 4 programs we see gives the same output and all are technically correct programs. So there is no hard and fast rule on which method should be chosen. The particular method is chosen depending upon the situation and how you want to solve a problem. So the question that which method is better totally depends upon the coder, that which method he or she should be choose. What is a reference variables? A reference variable is a nickname or alias for some other variable. So to declare a reference variable, we use the unary operator AND. First of all, before using the reference variable, we need the original variable. So we declared a variable int n is equal to 5. Then we declare a reference variable r with a unary operator AND. So we write int and r is equal to n, and we give it a reference of n. So this declares r as a reference to n. In this example, r is now a reference to n. It means that when we declare variable n is equal to 5, programs allocate a small storage to this variable n into the memory. So when we give the reference to this variable r, then they are both referring to the same storage location in the memory. To declare a reference variable and the AND operator after the type, the notation can become confusing when different sources place the AND differently. The following three declarations are equivalent: int space and r is equal to n, int and space r is equal to n, int space and space r is equal to n. The spacing between the int and the r is irrelevant. All three of these declared are as a reference variable that refer to the same variable n. You already know that our compiler did not read the white spaces. That's why all three of these declared R as a reference variable is a valid. Here is an example for the reference. In the main program, we declare a variable n, then we pass a value 10 to this variable. Then we make a reference. We take a variable r and gives it to a reference of x. So we write int and r is equal to x. Now r is a reference of our x. So we see out both x and r. Then we change the value of r. We write r is equal to 20. Changing r will change x. They are now names for the same storage location. So after changing the value of r, we again see out the value of x and r. In the output, we clearly see that before changing the value, when we set r as a reference to x, the output is equal to x is equal to 10 and r is equal to 10. Then we change the value of 20. After changing the value of r, when we see out x and r, we get the output x is equal to 20 and x is equal to r. The value of x change from 10 to 20 because r has the excess of the same storage as x. So in this program we create an integer x and then we create a reference r, which is a reference to an integer data type, and tell it to refer to x. Then we output both x and r, and it displays us x is equal to 10, r is equal to 10. After the first two lines, any uses of r is exactly the same as use of x, as demonstrated by the cout. It is said that the second line binds the reference r to x. Now back to our functions. We see this slide before, that is function calling. In calling program, write the name of the function and provide its argument without data types. In calling a function, return value type and data type of the arguments are not written. For example, we declare a function as void sum int n number 1 int number 2, then we write the body of the sum function int result is equal to num1 plus num2. And into the main program where we call it, we write sum num1 num2. Now when we write this function, or when we call this function from the main function where we write sum num1 num2, then these parameters num1 and num2 are called actual parameters. And when we define our sum function, then where we use these num1 and num2 parameters, the both parameters are called formal parameters. So passing arguments to a function. An argument is a piece of data, an int value for example, and passed from a program to the function. Arguments allow a function to operate with different values, or even to do different things depending on the requirement of the program calling. Each parameter type specifies the type of the value that should appear as a function argument when the function is called. For example, in the main program, we call a function with name func, and we pass it a value 42. Now this value 42 is called the actual parameter, or we set it as a argument. The function name is followed by bracket list of function arguments. So calling of a function, the function can be called using either of the following methods: call by value, call by reference, or we say that passing argument to a function. Arguments are passed in two ways: call by value or call by reference.